Welcome back to my YouTube channel, friends. So we were studying current electricity from class 10. So let's proceed. So in my last class we have discussed the Ohm's law. What was the Ohm's law? That was V equal to IR. Now the most important thing in this law is that this law is valid only in constant temperature. Constant temperature. Temperature means potential difference will be directly proportional to the current only when temperature will be constant. Why? Because from here we write R equal to V by I and R is constant according to the law. But this is valid when temperature is same or the conditions of the conductor is same. Why? Because when you change the temperature, suppose we increase or decrease the temperature, then the resistance is affected. It further does not remain constant when we affect the temperature. Later we will learn that resistance depends on length of the conductor and area of the conductor. So on increasing the temperature, there is something called thermal expansion which occurs, and as a result length increases. So this will affect the resistance. You will learn thermal expansion in class 11. It's a higher level topic, but for your knowledge I have given this because often it is asked in your Olympiads that how does the effect in temperature affect this Ohm's law? So your answer should be, when temperature is not constant, Ohm's law is not followed. Or inversely you can say, Ohm's law is only valid in constant temperature. Am I clear? So let's come to the next point. Now I would like to clarify a common doubt which almost all the students have in their mind. See what we will learn now. Okay, this was the Ohm's law. Let me write it again. This was the Ohm's law, V equal to IR. Fine. Now from this we can write R equal to V by I. So as you have seen, from here what you can write, that V is directly proportional to R, because you see, am I right? Yes, this is also correct. But after this many students ask that if V is directly proportional to R, then if we increase the potential difference, then the resistance of the circuit should also increase. But this is not a correct concept. This is wrong. Why wrong? Let us analyze. So from Ohm's law, what we have got? What is the basic definition of Ohm's law? It was that V is directly proportional to I. So as soon as you increase the V, I mean the potential difference, what will happen? Current will also increase, because when you increase V, it will increase current because it is directly proportional. And when current is increased, what will happen to the resistance? It should have decreased. So when you increase the potential difference, resistance will remain same. For increasing potential difference, it had to have increased, but also current increases, so it should have decreased, and this effect is nullified. Ultimately, in other words, you can say that resistance is just a proportionality constant we have defined. So you cannot sense resistance by sensing the current in the circuit. See, the concept is little deeper. When you increase the potential difference, then current will also increase, and ultimately V by I ratio will remain constant. let us take two cases. What happens? I will explain even further. Suppose for the first case, V is 1 volt, I is 2 volt. Then in second case, when you increase V to 2 volt, see, then current will always increase to, this is not volt, this is ampere, 4 ampere. Why? Because in both the cases V by I should remain constant, that is here also it is 1 by 2, and here also V by I ratio will be 1 by 2, and it should be constant because it is R and R is always constant. It is the until and unless you sense the resistor of the circuit, you cannot sense R. Obviously you can sense, later you will learn that R also depends on length of the conductor and area of the conductor. So by sensing this you can sense, that is another thing, but only by sensing the potential difference you cannot sense resistance or current. But the converse is true. This is very important. See, what we have learned, that when V is increased, potential is increased, then resistance will not increase. This will not happen. Or when current will decrease, resistance will not increase in both the cases. But when resistance will increase, current will obviously decrease. This is true. This is false. Why is it so? Because we have learned that resistance is the obstruction that is faced by the flow of electrons. And when obstruction will increase, obviously electron flow will decrease, and as a result, current will decrease. Are you getting my point? This is not true because R has to be constant. You cannot increase or decrease R. But I is not constant in a circuit. You can increase or decrease I by increasing or decreasing the resistance. But inversely you cannot do. That is the thing. By increasing potential difference you cannot increase R, or by decreasing potential difference you cannot decrease R. But by changing the resistance you can change the current in the circuit. This is an important point. And many students make mistake. So in your exams often question is asked. Let us move to a simple question. What is it? Suppose question will be asked that if V, or you see V is double, then R becomes this, and options will be double, this is B, second will be half, third will be remain same, and 4 will be none, or let's suppose none. Then many of the students will solve this as like, you see, V equal to I, so R equal to V by I. Now V is increased to 2V. So R dash means the new resistance will be 2V by I. You can write this as 2R. So R dash equal to 2R means it seems it is doubled, but this will be a wrong answer as we have learned. The answer will be remains same because resistance of a circuit is always constant with respect to voltage or the potential difference and the current in the circuit. Or you can say resistance of a circuit is independent of the potential difference across the two terminals of the battery as well as the current in the circuit. Hope it is clear. So further we need to study more in this chapter about the unit of resistance. Then we need to study the factors affecting resistances. So all this we will be studying in our next classes. We shall conclude today's class here. I have tried to explain a little bit about the potential, the resistance. So hope you have liked the video. If you have liked the video, please subscribe my channel